A moonpool is the opening in the floor or base of the hall, platform, or chamber, which gives sheltered access to the water body below, allowing equipment and fluid to enter or exit in a more protected environment compared to the deck. This feature is found in marine structures like drilling platforms, floating wind turbines, deep water vessels, and drill ships, to mention a few. The moonpool fluid region experiences reduced dynamic forces due to the external waves. However, this gives rise to large and complex water oscillation motions like sloshing or piston movements at some wave frequencies. In these cases, the water pressure acting on the moonpool surface must be carefully considered. In Aqwa Workbench, you can now perform a hydrodynamic diffraction analysis on floating structures with the moonpool. Using this feature, the fluid is split into an external fluid region around the floating structure and the moonpool internal fluid region. As a result, a multi-region fluid matching approach is developed. The moonpool internal fluid free surface condition is defined with the weighted summation of the predefined oscillatory pressure modes to model the large water column oscillation motions within the moonpool. To perform a moonpool analysis, there are some specific surface requirements which must be present in your geometry. They are the moonpool wall surfaces, the moonpool free surface, and the moonpool matching surface. The moonpool wall surfaces must correspond to the moonpool location. The surface normal should point inwards into the enclosed sea volume. The moonpool free surface is an abstract surface and corresponds to the surface of the moonpool at the water level. The surface normal should point upwards. The moonpool matching surface is also an abstract surface and corresponds to the portion of the moonpool walls through the structure's hull. The surface normal should point towards the enclosed sea volume, which will be upwards in most cases. To include a moonpool object in your model, select a part in the tree view, right-click the part and select Add, then Moonpool. You can define up to 10 moonpool objects per structure, and each object's details panel must be populated. Next, we'll select the moonpool bodies. To make it easier, let's hide the line body of our drill ship. The first body we'll define is the moonpool wall surfaces. In the details panel, click moonpool wall surfaces to enter selection mode. Zoom into your model and click the wall surfaces. You know it's been correctly selected when it turns green. Click Apply. Repeat these steps for the free and matching surfaces. If you need to release a moonpool body, just select it in the details panel. Click outside the model to remove the green highlight and then click Apply. You can now redefine more frequency points near the natural frequencies of the moonpool fluid and the peaks of the pressure mode RAO's amplitudes. In terms of pressure modes, you may define up to 20 of them for your project. In the details panel, you can also define the damping factor. To include hydrostatic results in the solution of your hydrodynamic diffraction analysis, including a Moonpool, right-click Solution and select Insert Results, then Hydrostatic.